Good morning, everybody. So today is another lab day. So what we're going to be doing today is an introduction to the idea of the chemical mole. So we're going to introduce this idea using a lab in which we take some common food items. So in this case, rice, beans, well, black beans and brown beans, and then rice. And we're going to simulate what chemists do to count atoms. So as you can imagine or know, that rice and beans, they're small items, right? So we don't want to, and we use a lot of them, right? So you think about, making some rice or beans or whatever for dinner or something like that. You're not sitting there counting out individual grains of rice, right? So that's not the way that we measure out these items. Or if you go and buy them in a store, you're not buying them based on the individual number of beans in a packet, right? So that's not the way that it's counted out. Okay. So chemists do the same thing with atoms. Obviously, we can't see atoms. So even if a chemist wanted to sit there and individually count out individual atoms, he can't do it, right? You can't see it. So chemists need a way, but they need a way to measure out different amounts of the specific amounts of different chemical quantities during a chemical reaction. So as we saw in our chemical equation, all chemical reactions are basically just a recipe. It's just like cooking, right? So when you go to cook something, you need specific ingredients, but with those specific ingredients, you don't just grab handfuls of them. You have specific quantities, you have amounts of each of the ingredients that you need in order to produce ultimately whatever it is the dish is that you're making. And a chemist needs the same thing. So when a chemist goes to produce a certain compound, produce a certain product, specific reactants are required and also specific numbers, just a specific quantity of each of the reactants are required. So same with cooking, the chemist doesn't simply grab handfuls of the reactants and toss them together. So that chemist needs a way to count out, quote unquote, count out the correct number of each of the reactants. So that's what we're going to look at today. So what chemists do is they invented a concept called the mole. So it's a weird name. I honestly haven't bothered to research where it comes from, but that's what it's called. So we're going to get a bit of an introduction to how that works today in our lab. But first, the warm up, we need to do this pattern recognition activity in which we're going to look at the 5 different classes of reactants or reactions and how they're defined. So if you go into your warm-up page, and I've already copied this into your personal folders there, so you can go in and look at it. So you're just going to read through there, and then there are 5 different reactions. So again, you can just write right in here. So I have one question at the end of each. So what you're doing is you're going to read the 3, or you're going to read the reaction, and for each reaction I've given you 4 examples of that reaction, and you're going to look at what they have in common. What is it? What patterns do you see here? And you're going to use those patterns to define what a decomposition reaction is. Right? So you're going to see what is the same on all of these. So that you're going to do that for each of the 5 reactions. So let me check off each one that you do. So then we can move on to the lab. So then we have our lab here. So we're going to begin with a little video. So please click on this to watch it. So this just is some background on the chemical mole. Okay, so here's our purpose, materials. So in this case, I've given you all the procedures, so I tell you exactly what to do. What I haven't done is set up your spreadsheet and stuff for you. Data analysis wise, I tell you what to do for the data analysis. So this particular lab consists of 2 parts. So we need to get some background measurements in part 1. So what we're going to do here is get the average mass of the rice and the 2 types of beans. And then we're going to utilize that average mass to see if we can count out specific numbers of beans and rice. So we want to count out 150 black beans. But again, we don't want to sit there. No one wants to sit there and count individual black beans, right? So we're going to use our average mass to test out the accuracy of this method. Can I count out 150 black beans without actually individually counting them? can I count them out using my average mass value? And this is what chemists do with chemical substances. Okay, so then you just follow through on that. Exit ticket wise, we're just cleaning up today. No homework today. So that's our activities for today.